So in problem number 2, we have this question that says, find the zeros of each equation, then write the equation in standard form and determine the multiplicity of each zero. So I'm going to do A, and I'm going to focus on the zeros and the multiplicity first. All right, so to find the zeros, you just set each factor equal to 0. So lucky us, we have the factors in standard form. So we just set the factor equal to 0. We don't have to factor anything. And then we solve. Well, this one's already solved for us. This one, subtract 4 from both sides, and you have x equals -2. This one, you add 2 to both sides, and you have x equals 2. So I found my 3 zeros. But now I want to determine the multiplicity, and that's really just asking you how many times did that 0 occur? How many factors did it come from? So x equals 0 came from this factor, and there's only one of those, so it has a multiplicity of 1. X equals -2 came from this factor right here, which is squared. That means it happened twice, so it has a multiplicity of 2. And x equals 2 came from this factor, which only happens once, so it has a multiplicity of 1. So we've handled this part of the instruction and this part of the instruction. Now we want to go ahead and write the equation in standard form. Now that just means multiply this out. We've got x times 2x plus 4 squared times x minus 2. Now, the thing you have to remember is that if you have a factor that's squared, that means multiply it times itself. So the first step in being able to put it in standard form is to write all of the factors out. The second step is to use the distributive property to multiply out. So, and you only do 2 at a time. So I'm going to use the distributive property, x times 2x and x times 4. So x times 2x is 2x squared, and x times 4 is 4x. And now that's a new factor, and these factors are still there, right? So this is new. I combined these by multiplying them, so I put them back in parentheses, and these factors are here. So we still need to use the distributive property to do. Now we're going to focus on these two factors and use the distributive property. Now you can do distributive property just kind of with arrows, so I'll show you that method. And then the next time I'll use the area model. So 2x squared times 2x is 2x to the third. 2x squared times 4 is 8x squared. 4x times 2x is positive 8x squared. And 4x times 4 is positive 16x. And now we need to combine like terms. So we have 2x to the third plus 16x squared plus 16x. That is all. These two times each other become that, but we still have this factor of x minus 2. So notice distributive property. You're just distributing everything to everything. This goes to those two, and this goes to those two. I actually prefer to organize the distributive property with the area model, so that's what I'm going to show this time. If you like distributive property the way I just showed you, you can do that here. But I'm going to show the area model in case you prefer that, and the area model could have worked up here too. So area model says, well, I've got 3 terms times 2 terms, so I need a 3 by 2 box, and I put these on the outside, 2x to the third, 16x squared, 16x, and then I put this on the outside here, x minus 2. And this just helps me make sure I've done everything times everything and gives it all their own space. So 2x to the third times x is 2x to the fourth, 16x squared times x is 16x to the third, 16x times x is 16x squared. Negative 2 times 2x to the third is negative 4x to the third. Negative 2 times 16x squared is negative 32x squared. And negative 2 times 16x is negative 32x. Now we just combine our like terms. 2x to the fourth doesn't have any, but these two are like terms, so that's positive 12x to the third. These two are like terms, so that's negative 16x squared, leaving negative 32x. This is our final standard form. Standard form means there's nothing, no factors to be multiplied out, and the degree of each term is in decreasing order. So this goes 4, 3, 2, 1. So this is my final standard form. Now, there's a lot of places that you can make mistakes when you're multiplying out or factoring. So one really good way to handle that, to check to see if we did our work right, is to take this equation and enter it into your graphing calculator. 2x to the 4th plus 12x to the 3rd minus 16x squared minus 32x. And then here, you go back to the original problem before you did any work. So this is your final work. And then you go back to the original one where no work had been done. And you enter that in, x times the factor of 2x plus 4 squared times the factor of x minus 2. And you graph it and you see if the graphs match. And if you did your multiplication correctly, they should match. So there's one graph, and we're not getting to see a lot of it, but it looks like maybe the graphs didn't match. So let's go and check on our y equals key and see. And it looks like, yeah, they didn't actually match. Some of it matches, like I have the same zeros, but it looks like I'm off on some other parts. So this is perfect. This means I made a mistake somewhere and I need to go back and find it. So let's check the work again. So I wrote this out twice. So x times 2x squared is 2x squared. X times 4x is 4x. So I feel pretty good about that one. Now, this one right here, I multiplied together. And I did the distributive property. And right away, I'm seeing a mistake. 2x squared times 2x is 4x to the 3rd. So that's right there is a mistake. So maybe that's my only mistake if I'm lucky. So if that's my only mistake, that would change this, right? Then that would mean this would be 4x to the 4th, and this would be negative 8x to the 3rd. And that would make these two positive 8. So see, this is another, oops, I didn't show you that. This is another reason why I like the box, is because once I found this mistake, it was actually easy to tell what other things needed to be changed. I needed to change this term, and then I needed to change anything related to that term. So this one and this one. And then this one had combined with that one, which I could see clearly, so I needed to change that. So it showed me everything that I needed to change. That's another reason why I like the area model. So let's go back. And so also this needs to be changed to 4. So let's go back and see if that fixes things. This is 4x to the 4th. And this is 8x to the 3rd. Let's see if this graph matches better now that we've fixed it. And it's looking pretty good because I remember that curve from the last one. And I'm not seeing any other thing appear, but let me just check my table to be sure. Are the values consistently the same? Yes. So I was able to use my graphing calculator to check for a mistake, go back and find the mistake and correct my mistake. So don't forget to do that yourself on your test, and especially on the North Carolina final where there's plenty of time for you to do that kind of checking.